So, in this lesson today, it's still working on acids and alkalis, but we're going to look at a topic called insoluble products. So, what we'll be looking at is the reactions of acids and alkalis, but we'll be looking at the products that are formed and being able to determine whether or not they are soluble or insoluble, because that matters. So, we're just going to quickly go over what happens in our reactions. So a metal plus a metal oxide, plus an acid gives us salt and water. Our metal hydroxide plus acid does the same thing and gives us salt plus water. And what we'll be looking at again is metal carbonates plus, so just one, produces a salt plus water plus carbon dioxide. So when we're talking about insoluble products, we're not talking about water, because water is a liquid, and we're not talking about carbon dioxide, because carbon dioxide is a gas, and in the reaction, the carbon dioxide will bubble away, so we don't need to worry about that. What we're really talking about, whenever we're talking about insoluble products, is the salt. And we already know how to name salts and predict salts from our starting materials. But the question now becomes, how do we know whether or not the salt is soluble or not? Now, one way is we get the name of the salt and we use the data booklet. That's one way we can tell. So, insoluble salt. Insoluble salt, we can look up the data booklet. And in the data booklet, that is page 8 for the National 5 data booklet. So I'll just show you that. So this is page 8 of the data booklet at the bottom. And we have on this page, I know it's not the easiest to see. Oh, zoom in there. But we've got a list of different metals, or positive ions, here, and a list of different compounds. And on this, what you're able to see, if you're looking at this along with me, is that we've got a key up at the top. So VS and S, those ones are soluble. So we're not worried about those. We're not concerned about those at all. The only ones we are worried about are the ones here where it says that it is insoluble, and that's a letter I. So if we look in the table, so we'll look along, aluminium is the top one, and we've got quite a lot of soluble, very soluble, very soluble. Then we come to phosphate. That one's insoluble. So if that salt is produced, it's going to be an insoluble product. Another one, let's look for sodium. Well, if we look along sodium, it's 3 from the bottom. It has no insoluble salts from this table. So if sodium's involved, we don't need to worry. Then magnesium. Well, magnesium's got a mixture. The magnesium carbonate is insoluble, magnesium phosphate is insoluble, magnesium oxide and hydroxide are insoluble. So if any of those form, we'd call it an insoluble product. And that's what we're looking for. So that's the main way that you can tell. is by looking at that. But other clues can help you as well. And sometimes they might use a chemical in an exam question that's not in the data booklet, that you cannot look it up directly. And so there are other ways. And this is where we come to looking at state symbols in chemical equations. So whenever we have a chemical equation, we often see beside the chemical small things in brackets. So for example, sodium hydroxide, we might see AQ written like that. Now sodium metal, we'd see something like that with an S. Water, we'd pretty much always see water with an L. And carbon dioxide, we'd see it with a G. Now these things here are our state symbols, things that we call our state symbols. So we've got G, we've got an L, we have got an S, and we also have a Q. And what those symbols tell us is what physical state those chemicals are in. So we'll start at the bottom and we will look at carbon dioxide. Well, we know that carbon dioxide, it's in the air. When we breathe it out, we also know if it's produced in a reaction, we get bubbles. So that is a gas. So for a gas, you get the chemicals, and then we get that symbol beside it. Now water, what that means, the L is for liquid. With this one, sodium metal, it's a solid, and that's what the L stands for. And those ones were probably quite obvious. G for gas, L for liquid, S for solid. The one at the top is probably the one that you would need to work out. You might need a little bit of help to understand. Now what the AQ stands for is aqueous. And what that means is that it is dissolved in water. And it gets the AQ. Now what you'll find is that most acids and all alkalis, because an alkali is a soluble base, are AQ. And that means that everything at the start of a reaction, for a neutralisation, an acid reacting with an alkali, should be AQ. And then, when we get the products, we know we're going to produce water, that's going to be a liquid. If one of our starting materials is a carbonate, we know we're going to get carbon dioxide, which is a gas. And then we get the salt. So let me just write that out. So acid plus alkali goes to salt plus water. Didn't really write that one out particularly well, did I? But our starting, this one is going to be AQ. This alkali, that's going to be AQ as well, if it's an alkali. Some bases might be solid, but alkalis are always going to be that. water is a liquid, and we'll see that symbol. We might, if the alkali is a carbonate, so we might see carbon dioxide. And if we do, it'll be a gas. So what's going to determine if we've got an insoluble product is this one here. The salt will sometimes be a solid and sometimes, and it'll sometimes be aqueous. Now, if the salt is AQ, then it's we describe it as soluble. If the salt is solid, it's insoluble. And if our reactants are soluble, but our product is insoluble, we call that a precipitation reaction. So it's still a neutralisation reaction, but if we get a solid product that's insoluble, we call it precipitation. So if the product is insoluble, but the reactants are soluble, we call it a precipitation reaction. And so we're always looking for if this is soluble or if that's not soluble. And that's really all there is to it. So there are two ways of finding if out a product is insoluble. The first one is using page 8 of the data booklet. So from the name of the salt, we can look up the data booklet. Or if we are in a situation where we've got an equation written and we see state symbols, AQ for dissolved in water, S for solid, L for liquid, G for gas, then we can follow the rule that if the reactants are soluble and the product is insoluble, we've got a precipitation reaction. So that's our key word, but being able to work out if something is soluble or insoluble, either from the state symbol or the data booklet, is an important skill for this acids and alkalis topic. So that was what we covered today. I hope that makes sense for you. Thank you for your attention.